Here we're going to look at a actual real PEP8 program, and actual how we should really be handling our local variables. So we're going to step through and convert over this C++ program. It doesn't do anything too exciting. Declares a constant, sets it to 5, declares 3 local integers, inputs those two integers, then does an average. So this is a program we already looked at. Just previously when we looked at it, we did it with global variables. Now we're doing it with local variables. So there's what the program looks like. So if we walk through it, we start out with our constant gets evaluated or declared the same as we did before. We use the .equate, and since we want that constant to have a value 5, we just straight up set it to the value 5. Now when we get to the actual variables, the next step, our 3 variables are going to be, so we've got exam1, exam2, and score. So we're going to put them in here as exam1, exam2, and score. Now these also get done as equates, but remember, equates aren't actually allocating any space. Remember, the equate, all it does is create an entry in the symbol table so that when the assembler runs through the program, it can go through later on and replace the values, replace all the labels with those values. So what we're actually doing here is we're not saying how much memory to store, we're saying where to store them on the stack. So our first variable, which happens to be the third one, we start at the bottom, so that the score variable is going to be stored at offset 0 on the stack. Since we're storing integers, we need to allocate 2 bytes for it. So the second variable is going to be stored at address or offset 2 on the stack, and the third one's going to be at offset 4 on the stack. So if we were looking at these on the stack, we'd see our score, then 2 bytes above it we'd see exam2, then 2 bytes above that we'd see exam1. And keep in mind, this bonus up here is totally independent of that. That bonus is its own separate equate statement that's there for a constant that has nothing to do with the stack. So these equates to say where the variables are going to be on the stack, we still need to allocate the space, and that's what we do with this subsp command. So the subsp 6i, remember I is immediate, so it's actually saying subtract 6 from the stack pointer, so that's what's actually allocating 6 bytes of space on the stack. Again, we've got 3 integers, each integer is 2 bytes, so we're allocating 6 bytes for those 3 variables. Once we've done that, once we've allocated that space, from there on, the program runs this. If you can go back and compare this to the program we looked at before with global variables, it's exactly the same. The only thing that's different is that we're using S when we're accessing our variables because they're now on the stack instead of being global. When they were global, we used D. Now that they're on the stack, we use S. Once we run through the program, when we're done using all those variables, we have to return the address back to the stack, so that's where we do this add sp. So the add sp is the exact inverse of when we were allocating space. We allocated space with sub sp6, now we deallocate space with add sp6, so we're giving those 6 bytes back. And that's it, really. That's when you're using local variables, that's the process. You use the labels with the .equate to say where they're going to be on the stack, always starting at 0. So the first one is 0, and then depending on whether it's an integer or a character or a string, you can do a string too, but you allocate as many bytes as you want. The second one the second variable you put on there needs to make sure that it has left enough space for the variable before it. Once you have all your equates in there, you do the sub sp. Based on how many bytes you've allocated, use sub sp that amount to make it available on the stack to actually use. And then your whole program is, like I said, as normal, just using S for your variables instead of D's. And then when you're done, you do the add sp. So now what I want to do, I'm going to take this program and actually put it in PEP8 so we can actually walk it through, but I'm going to do that in another separate video.